When addition and subtraction of rational numbers always shows up, it's understandable to be annoyed. They often aren't always easy to solve, especially when you're new to math. Luckily, when we add and subtract rational expressions, they follow the same method used with rational numbers. Let's take a look. When adding rational numbers, you're going to be confronted with one of two problems. You're going to have the easy problem or the hard problem. Let's start with the easy problem. Let's say you have two rational numbers, and the denominators are the same, such as 2 over 7 plus 3 over 7. You would simply keep the denominators the same and add the numerators, 5 over 7. But when the denominators are different, you have to look for the LCD, or the least common denominator. The main idea is rational numbers can only be added or subtracted if their denominators are the same. Let's say we have 1 over 3 plus 3 over 7. The LCD of 3 and 7 is 21. So we need both denominators to be 21. So we need to find a term to multiply both the numerator and denominator by to make the denominator equal to the LCD. In our case, if we multiply the numerator and denominator of the first term by 7 and do the same with the second term but with 3, we'll get 7 over 21 plus 9 over 21, which equals 16 over 21. In all honesty, this is something that gets better with practice. Let's try our luck with adding two rational expressions. Let's try adding x plus 1 divided by x minus 1 plus x plus 2 divided by x minus 3. First, we'll notice that the denominators are different. So we'll need to first find the LCD of the two denominators. It might not seem intuitive at first, but remember how we found the LCD with our rational numbers, 1 over 3 plus 3 over 7. Our least common denominator there was 3 times 7, which is 21. And we multiply both parts of each fraction by whatever number that would give us our denominator of 21. We're going to do the same thing here. Our LCD is the product of both our denominators, x minus 1 times x minus 3. Now don't go too quickly. We don't need to multiply these two binomials together. You'll see why in a moment. Look at the first term. Its denominator already has an x minus 1. So let's multiply both parts by x minus 3. We'll then do the same for the second term. Its denominator already has a x minus 3. So we'll multiply both parts by x minus 1. We'll now have x minus 3 times x plus 1 divided by x minus 3 times x minus 1 plus x plus 2 times x minus 1 divided by x minus 3 times x minus 1. Our two terms now have the same denominator, meaning we can begin to add our two rational expressions together. X minus 3 times x plus 1 plus x plus 2 times x minus 1, all divided by x minus 3 times x minus 1. There's nothing that we can currently factor out to simplify, so let's go ahead and multiply our binomials in the numerator together. X squared minus 2x minus 3 plus x squared plus x minus 2, all divided by x minus 1 times x minus 3. We can finally add the two polynomials in the numerator. 2x squared minus x minus 5, all divided by x minus 1 times x minus 3. You may wonder why I didn't multiply the two binomials in the denominator. While it's okay if you do, it's better if we leave it like this, because now we can see that for this specific expression, x cannot equal 1 or 3, because we can never divide by 0. Let's practice a few more examples. Number 1. 6 divided by x plus 3 plus x divided by x plus 3. Our first example is a simple one. We have two rational expressions with equal denominators. This means all we have to do is simply add the denominators. 6 plus x divided by x plus 3, or x plus 6 divided by x plus 3. Remember, sometimes it's more conventional to keep the variables in the front of the expression. Number 2, 3 minus 1 divided by 5x plus 4. Now we have a rational expression being subtracted from a whole number. For subtraction, the rules are the same as addition. Remember, subtraction is simply addition with negatives. Our first step is to visualize 3 as a rational number. That is 3 over 1. So we have 3 over 1 minus 1 divided by 5x plus 4. We know by the identity property of multiplication that anything multiplied by 1 stays the same. So our least common denominator is 5x plus 4. We can multiply both parts of the first term by this to get a fraction ready for addition. 3 times 5x plus 4, all divided by 5x plus 4, minus 1 divided by 5x plus 4. We can now add our expressions, which becomes 15x plus 11 divided by 5x plus 4. Number 3, 3x divided by x minus 4 minus x plus 5 divided by 2x plus 3. We have two full rational expressions to be added. Our first step is to identify the LCD, which is x minus 4 times 2x plus 3. We then multiply both parts of each term by the appropriate factor. 3x times 2x plus 3 divided by x minus 4 times 2x plus 3 minus x minus 4 times x plus 5, all divided by x minus 4 times 2x plus 3. Now that our denominators are the same, we can successively add our numerators together. 3x times 2x plus 3 minus x minus 4 times 2x plus 3, all divided by x minus 4 times 2x plus 3. We have to be careful with the second term because it's being subtracted. Multiplying the binomials gives us 6x squared plus 9x minus the polynomial x squared plus x minus 20, all divided by x minus 4 times 2x plus 3. We can now simplify the numerator. 5x squared plus 8x plus 20, all divided by x minus 4 times 2x plus 3. This lesson, along with the previous lesson, showed us that we can use the same method to add and multiply rational expressions as we've done with rational numbers. It's important that we learn to master operating with rational expressions. They become fundamental when you move on into calculus. The next lesson will be the last for this chapter. We'll look at complex fractions, which is fractions inside of fractions.